Hi, I'm John Conveyor. I'm one of the other developers here at Tag Creative. I was one of the main people that put together Yeti Build for you guys, and I'm going to walk you through more of the game details here. So we'll really deep dig down into some of the lower level systems to create a game. There we go. So here's our agenda. I'm going to walk you through how you get input from the DOM to the game, our entity system, sprites, and how do you do animation so your guys actually are lively. Entity movement, entity collision. We'll do a little bit of sound in HTML5, and then just a little bit of a talk on performance, because given HTML5, that's actually a fairly large concern. So let's get started. So first up, we got the keyboard input. We're gonna So basically, if you've worked in JavaScript and event listeners, it's kind of the same idea. We're going to add a keydown event to the window and attach a event listener to it. Our event listener, when the user presses the key, the event listener will fire, and then we need to check the event that gets passed to that, and that'll return our key code. Our key code, there's a bunch of ASCII key codes that you pretty much can Google and find the whole list. Our main ones are going to be like spacebar, left arrow, right arrow for Yeti Ball. Here, this is an example. Spacebar is key code 32. Usually when you're building out games, it's best to create like a function that's like an enum, and then you can just keep track of those in readable code. But for now, that's the basic key code there. Alright. Next up, I'm going to show you the DOM input. So this is the code for the snowball button. So this one's going to use a special Windows MS specific class here, event. It's going to pass the MS pointer up. This is useful because it helps indicate for touch systems a little better than the normal click event does. And this ties into the game system more. So on our MS pointer up, we're gonna fire the game.system.input.snowball. That is essentially a function that lives in the game system namespace, and it lets us, by writing it that way, it lets us call it from multiple places. So if we theoretically wanted to extend the game in the future, we could just call that event in, like, say you shake the device or had some special input there, you could just call the snowball, and that will allow you to have the same behavior using the similar code. And you'll see in the snowball function, we just set a variable to true, and that's going to be used later on in our update loops for our entities that will pull that position. So here's just a little wrapper just so you're able to do crossbars a little better. You're just going to check if the MS pointer enable exists. If it does, you're going to set the namespace to that. Else you're just going to default to the click button there. And then, like here, you can see that it also gets set to the DOM input.snowball function. Right. Next up is the entities. So these guys, entities are basically in any game one of the main components to your game. Entities are pretty much any object in your game that has like a special behavior. It moves around, collides, like bullets in most games are entities even. So, and entities essentially are just storage. They have a data that they store. So they're like objects in an object-oriented language. So they store your data. In our game, our hiker is one of our main entities. It stores position, its image, which is the sprite sheet that we'll use, its velocity, which is basically the direction it's traveling, and then it has a bunch of other states to it, like we'll have like, am I alive, did I get hit by a snowball, that kind of thing. So you see here, this is, sorry. So this is our example in game. So every update loop, our position and our velocity is going to get updated for these hikers based on player input, other entities, where they're at in the game, that kind of behavior. So we've got 3 hikers on our screen, and they're all going to be using like a hiker class that they derive from, but each one's going to have its own set of data. So as you can see, the blue hiker knows its position independently of the green and the red hiker, and their velocities all different. And so you basically have a class, and then you create different objects of that class for an entity. Right, here's a bunch of code I'm going to throw at you. So this is a really simple implementation of the hiker class. So as Patrick was talking about in the last talk, the game loop, every tick, first it's going to load up. It's going to call this init function over here. You're going to pass that. The hiker data comes from another manager we have, but that's essentially like what image are you, where's your starting position, that kind of thing, that you can pass there. And so that's going to basically load in the image for us and set our base variables. In the actual game, that does a little more. Let's see if I can pull it up for you. This one, got it. There we go, nice and big. So as you see, we've got our frame sizes. That's going to be something we can talk about later, but that's if you're doing like high-res assets for higher resolution displays. Our target points are the pathfinding list we'll use, which is essentially the hiker behavior. And then we've got a bunch of stuff in there like position and last, which is used for interpolation. Let's get back to the slideshow. So as I said, that's the init. The update's essentially the same in the draw, and these are called by our master game loop. Every update tick, every draw tick. These are the thing that actually gets called. So now that you've seen how an entity gets created, let's talk about how they actually get animated with sprite sheets. So sprite sheets are basically your animation frames. For our Yeti, very simply, it just has 3 frames. If you wanted a little more resolution to it, you'd have like maybe some games have like 20 frames, or depending on how much quality you want in the animation. So essentially, it's going to just walk through the frames each update loop, and that just gives you the illusion of movement between the animation. So as you see here, we'll have an update. It'll do frame 1, the first update, and then so many ticks later it'll be like, I need to go to the next frame. It'll hit frame 2, and then a couple ticks later it'll hit frame 3 in this loop, and that'll give you the motion of the Yeti going back and forth. But this is all one image that you're loading in. These are not separate images, and that's done for several reasons. Like in the web environment, you have to worry about load times, because that's a big concern, pulling stuff from the network. And just like, it's better for like memory concerns too, because you're saving less on header. You're saving a lot on header information for each image. And yeah, so that's basically animation there. The hikers are a single frame, and we do some tricks with those to get their animation, but they are not sprite sheets. Only the Yeti in this current version is the sprite sheet. Alright, let's move on to collision here. Collision is, for Yeti Bowl, since this is a demo, we implemented pretty much the easiest collision system possible, which is basically circle versus circle collision. This is essentially for each entity, which is our entities here are the snowball and the hiker. They're going to have a collision radius that you set to them. This radius is going to determine the circle around the entity from like the middle of it that its collision area is. And the math behind that is going to be if the radius is, or the length of the radius is, or the sum of the length of the radius is less than the collision radius, then the objects have collided. So you can see that in the second part here, we have where they're colliding. You can see that the length between the two entities, the two red dots, the radiuses of either one is greater than the length, so they have collided. Things like these, there's a lot of math properties you can use in these 2D games, like geometric properties that let you do cool tricks like this, that make things that could be really complicated a lot simpler. And this is just one of them. And there's other things. This can also be extended out further. Of course, this works better if your objects are circles like the snowball, so keep that in mind. But you could also extend this out to other entities. Don't necessarily have to have one collision radius to them. So you could theoretically, if you had something really tall, you could have like 3 circles that represented the collision box for that. And then of course, if you want, depending on your entity, it could also be a collision box. So it's a little more complicated, but not too much. Pull up the collision for you. Alright, so here's essentially all the collision code we have. So each update tick, the hiker entity is going to check to see if it's collided with the snowball. So our first line, we're just going to get the vector between the 2 points, which is this dot position is the hiker's position, and then it's going to check against the snowball position. The difference between that is the vector 2, and then we've got a helper function that we wrote that gives you the length, and then we just check if that's greater than the sum of the 2 collision radiuses, and then if it is, then we know a collision has happened, and then we just have code inside that block to handle that collision, and it also notifies the snowball with the vector, which allows us to do responsive movement in the direction the snowball hit. So alright, next up is going to be sound. So here's a very, very simple example about how to put sound in your HTML5 game. Essentially, it's just like an image element, just using audio, the audio tag. You're going to pass it a path to your MP3, and that's going to start the load-in process. And then when you want to play it, you play the audio sample. There's definitely a lot of caveats to HTML5 audio. First, if you want a multi-channel sound, which means you want the same sound to play multiple times at once. For instance, if you have like a snowball collision, you'd want the collision sound to happen multiple times as you hit multiple hikers. You actually have to load in the sample, duplicate the samples multiple times, because an HTML5 audio element won't play more than once. However, the audio sample does have a lot of properties that let you do cool stuff with it. It's got a looping property for music, so that's built in for you. It's got current time properties if you need to time it up with any sort of events. And just like, for images, they have the onload function, which you need to check to make sure it's playing or able to be seen. Audio samples are going to be, instead of onload, they have on-can playthrough, which is going to fire an event when the audio sample has enough information to start playing. But audio is definitely one of the parts of HTML5 that's coming along slower than the graphics properties, so it's definitely something you have to worry about more than the graphics if you have really elaborate audio to your game. So that's the sound. Right, and now I'm gonna just do a couple talks about performance. So, big thing about performance with HTML5 games is only draw what you need. The canvas draw image function is super expensive, and it's worse on mobile devices even. So the best way to optimize that is just to not draw it if you don't need to. So like Patrick was talking about in the last talk, the sky only needs to be rendered once because it never changes, and anything you can do to draw less is just great. But a lot of those are dependent on your game, so those kind of performance tweaks happen organically almost. I know a more complicated technique to draw less is you only clear the frame based on what was drawn last frame, but that's a more advanced topic that you guys can look up later. So for example, in our game we have all our hikers have a face to them, and this is going to be independent of the hiker image, and we composite those together before the game runs so that we only have to draw one image instead of two. So anything like that's really useful. If you can do it, basically if you can do it during load, do it, so you don't have to draw multiple images during the actual draw loop. And like I said, the sky is applied just once, which is an actual really cool property of using HTML5 games, is that you can leverage the DOM to do a lot of stuff. Like anything, typically the way we structure it is anything that has a lot of movement or a lot of updates, you're going to need to draw on the canvas, but anything else, just draw it to the DOM, and so you're saving a lot of performance there, because you only need, once you draw it to the DOM, it's good to go. Next is reusing objects. That's a lot of the properties of JavaScript is you kind of still have to watch out about the garbage collector. Even though they've got pretty smart, it's gonna kill you if you hit it too hard. So in our game loops, we initialize a lot of the stuff at start time. So like as you saw, we'll load in the images at start time, and then we'll just keep those around the whole time. And typically all our entities are created at game load time, and very few of them are loaded during gameplay or deleted during gameplay. Usually if an entity needs, say we have 5 hikers, if one dies, we'll just keep that data around and reset the data properties instead of deleting the memory and then calling a completely new one. So stuff like that's really useful to maximize the JavaScript use. Another one is, and this one's just kind of thing to know, is when you're drawing to the canvas, you want to pass integers to it, because floats cause anti-aliasing to trigger, which is where it tries to interpolate between 2 pixels. Traditionally we found this is just really slow whenever you try it, so you really want to avoid passing anything but integers to your canvas. And I'm going to show you our draw color ahead. So you see we have a draw function. This is our frame class, which is kind of our helper function for most of our entities, and it kind of wraps our canvas draw call here down below in draw image. So as you see, whenever we pass anything to it from any entity, we just round it with this special property here. The pipe 0 property is basically just a bitwise rounding for an integer, which is very useful because calling any math.round is actually fairly expensive, because especially if you're drawing something, say 60 frames per second, and each entity needs to call that again, so it adds up quite quickly. So not calling a function and just using a bitwise operator is much cheaper in this situation, and rounding up or down doesn't really matter, so we just kind of cut off, that basically just cuts off all the the floating point bits for you. And then you can see here is where we actually draw the image, which, as you saw in the last, as you may have seen in the last presentation, we set our source XY, our size, our target XY, and our current size, which we scale if we need to for each entity. All right, that's kind of the whole slide deck for this one. Are there questions or areas you would like me to look into, or of the code that you would like me to go into more detail about, or I guess I can show you guys the entity class that we create. So this is our entity class here, and every entity in the game derives from this, and it lets us basically have a system where we just override the information for each entity needed. But as you can see, like, a lot of entities use the same thing. Like, every entity is pretty much going to need an image. It needs to know if it's loaded, its state, which is the state machines like Patrick was talking earlier, and then there's our frames, which is useful for our Yeti drawing. In our update, I have it set up so we have a pre and a post, which are essentially just there for our interpolation calls, because entities need to know their last frame position for interpolation. And then almost every entity just draws with this call, because it just calls a frame that's set up by our initial properties. And then, as you can see here, the hiker entity just overrides updates, and then within the game, I'll show you where we actually do the run loop here. So the game definitely works in offline mode. If you pretty much have downloaded all the assets, you can just pull it and it'll work. If you wanted to get more advanced, there's definitely ways you could download that for a user, like by using local storage and things like that stick around. But currently, it's just if they put up a zip file and you download it, you can just run it locally, and it would work just fine. Nothing about this needs actual network connectivity for this game. So here's our update loop, and as you can see, basically, here's a really simple version of it. Our updates is it basically just cycles through our entities for how many entities you have, and then if they're not dead, then we update them, and else we clean them up, which basically frees up the memory for a new entity to be created. And most of our entities get created with this spawn entity function we have created. So we just pass the type, and then the spawn entity just creates an entity of that type. Certain things like hikers also have the ability to set specific properties for that type. So there's no, for layers and canvas, so there's none built in per se, but you very much can create them yourself. Essentially you can overlap canvases to create layers, because any point in the canvas that is transparent will just draw the one below it, so you can create your layer system. Yeah, correct, just by layering canvas is transparency. So unfortunately, to do that, you'd have to build out the engine to create that. I don't think there's any HTML5 engines that implement that yet, but it is very much possible to do that. And yes, that is very good for performance, depending on what you're drawing, because you can do stuff like maybe your background only needs to update half as much as your like actual player entity, and you'll still, like, the user will never notice because it's just a background, but so you're saving a lot of performance and the user doesn't mind. So but I think, what else can I show you guys, unless you have any more questions that I can cover. Yeah, I don't know any books for HTML5 per se. Pretty much, there's a lot of stuff out there for it. I actually am a fan of the Reddit HTML5 group, so it's like reddit.r/HTML5. There's a lot of great links in there, and discussions around HTML5. It's not necessarily game specific, but it's usually helpful for games anyway. But other than that, there's tons of resources out there for HTML5 because it's pretty much one of the hotter tech ideas right now. So it's, I know there's a big Stack Overflow section on game dev, and that'll probably have a decent amount of HTML5 in there. But that's pretty much I mean, for a lot of this stuff, so if you're building a game in HTML5, I found that although it's HTML5, you also need to focus a lot on like older graphics practices that may have been forgotten in this new age of fast processors. So just like reading up on, I like to read up on like how they built stuff in like NES days, and that'll give you a lot of like graphics performance boosts and stuff like that. Yes, I can show you the all right, go to the main game loop. Zoom out. Okay, so this is our main run loop here. Alright, so first, this .run is called in a set interval. And then first thing we do is we're going to get the time between last ticks. And then, which is basically the last time we've rendered a frame. When that's greater than our desired game tick, which for this one I believe is 30 frames per second, it's going to run an update, and then it'll say minus that 30 frames per second, and then if we need to update again to catch up, it will. And then once it's all caught up with updates, it's going to run down here to the draw code. There's some stuff about pausing, but essentially it's going to request the animation frame for the draw call and pass it interpolation values. And then I'll show you the draw in a second, but that's the main game loop here. And then at the end, we'll just record the last time we updated or ran the draw loop. So let me show you the draw real fast. So this is our main game here, so kind of just focus on this. I got to say before, it's really similar to the update loop. And so essentially we're just going, first we need to clear the rect, which is clearing the canvas. That essentially just clears out any pixels from the last frame. Otherwise you'll get stuff like artifacts in the last frame. And then we're just basically looping through entities that are alive and then drawing them to the screen. And then our UI draw is just for special score stuff. But essentially, that's your draw loop there. And everything's just contained within each entity class, how it likes to draw. So, yeah, definitely there's power, but yeah, definitely you have to, especially for HTML5, you have to be concerned about, like, you're not just drawing, you're not just running on high-powered desktops, right? Like, HTML5's dream is that you're writing it anywhere. And so you definitely have to be concerned about, like, performance, because you don't know if people are going to run this on their phone or their super gaming PC or a Surface tablet. So you have to think about this. Like, you can't stop people from going to your website because they're on these old devices, because they'll just like complain. So yeah, you definitely need to worry about stuff like resources, and request animation frames a nice one, because like Patrick was saying, so that shuts down if things aren't in view, and then it matches your monitor refresh rate, so that helps out. So the reason the render loop doesn't run on a different thread than the update loop, theoretically there's no reason it can't. Pretty much didn't do it for the demo because we didn't want to show you how web workers work in a simple demo here. But it's definitely, the way it's structured is definitely nice for that, and something, if you wanted to extend this to a real game, would be very much possible. So yes, one thing you have to do, remember those web workers, which are the HTML5 threads. They cannot access DOM elements, so you have to structure things really precisely. So your draw loop basically has to run on the main one, but maybe you could send off the update loop to a web worker, and that could return a game state that the draw loop just consumes in a separate thread. All right, well, that's it. I think we're going to go to break again, and we'll be back in a little bit with the next slide. So thanks.